Good morning. Welcome back to the value added course on Python. Today our discussion will be on Numpy library. The basic Python has some built-in features. There are some third-party libraries which are most important for data analysis. One such library is Numpy. In part 1, we are going to discuss about basic operations of what is Numpy. Our agenda today will be introduction to NumPy, and we'll be defining what is array, what is NumPy array, and how indexing and slicing can be done on arrays, and various operations that can be performed on arrays. Array. An array is a data type used to store multiple values using single identifier, that is variable name. An array contains an ordered collection of data elements where each element is of the same type and can be referred by its index, that is the position of that particular value. In NumPy array, which are stored list of numerical data, vectors and matrices, the NumPy library has a large set of routines, that is built-in functions for creating, manipulating and transforming NumPy arrays. Python language also has an array data structure, but it is not as versatile as the NumPy array. And NumPy array is efficient and very useful as the NumPy array. So NumPy stands for numerical Python. It is the fundamental package required for high performance computing and data analysis. NumPy is also important for numerical computations in Python because it is designed for efficiency on large arrays of data. It also provides the following functionalities: n-dimensional array, that is ND array, for creating multiple dimensional arrays to speed up data processing. Internally, it stores the data in a contiguous memory blocks, independent of other built-in Python objects, use much memory less than the built-in Python sequences. So these are the advantages of using the NumPy array instead of the default array that comes with Python programming language. The standard math functions for fast operation on entire arrays of data without having to write loops. That is, in normal Python, we'll have to write loops and execute various functions. Here, you need not to write loops. And similarly, NumPy arrays are most important because they enable you to express batch operation on data without writing any for loops. It is called as vectorization. The procedure for installing NumPy can be installed by typing the following command: pip install NumPy. And NumPy ND array, one of the key features of NumPy is its n-dimensional array object, or ND array, which is fast, flexible container for large data sets in Python. The NumPy-based algorithms are generally 10 to 100 times faster than the pure Python counterparts and uses significantly less memory. For example, if you are going to have the code, if you are going to have an array created using arange, that is NumPy function, of some 1 lakh numbers, and the same is used for creating a range of numbers using list, the time taken by NP array is very less when compared to the list, which is the default function that comes with NumPy. N-dimensional array is used for storage of homogeneous data, that is, all the elements are going to be of same type. Every array must have a shape and a data type. ND array supports convenient slicing, indexing, and efficient vectorized computation methods, for which the numpy is wanted. Now we'll look at the procedure for creating a numpy array and we'll see the various functions. Import NumPy as NP. So since it's a third-party library, before using NumPy, you'll have to import it, and you can have an alias name. So instead of every time typing NumPy, you can have an alias name called NP. So here we are going to have a list called data1 with the numbers like 6, 7.5, and so on. And you are going to convert it as an NumPy array by using a function called np.array, and we are passing this list as parameter. Now array 1 will be a NumPy array. Now we can print this NumPy array using the print function. We can fetch what is the data type of this particular NumPy array with the dot d type, and we can find the shape of this NumPy array using dot shape function, and with the dot mdim function, we can find out the dimensionality. Since this is going to be a one-dimensional array, your result will be 1, and the shape we are going to have the number of elements available in this particular NumPy. So the difference between list and array. So list is data structure available in Python, and array is another function. If you compare these two listed array, and further we will be comparing array with nd array, so that we can find out the difference between these three similar entities. So list can have elements of different data types. For example, 1, 2, 3, you can have text, symbols, and so on. So list can be of different data type. An array, it is going to be of the same data type. So we are going to have, if it is going to be numbers, it is going to be numbers alone. So same data type. So list elements of the list are not stored in continuously in memory. So here array is going to be continuously stored in memory. So this makes the array faster than list. So that's a reason for using array. It is going to be faster than list. Lists do not support the element-wise operation, for example, addition, multiplication, etc., because it is of different data type. Array supports element-wise operations like you can multiply an array elements by a single value, or you can divide the elements of an array, and so on. Arithmetic operation with respect to elements of an array can be performed. List can contain objects of different data type that Python must store the type information for every element. So it is a list. If it is containing different type of elements, it has to store what is the type also. But the NumPy array takes up less space in memory as compared to the list, because arrays do not require to store data type of each element separately. And list is a part of core Python, where this nd array is a part of NumPy library, which is a third-party library function. Now, important attributes of NumPy or nd array object is, you can we are going to have examples, 3 arrays: array 1 with values 10, 20, 30, and array 2 with different values, and similarly array 3 with 3 lists. So all these 3 are converted into one NumPy array. Now we'll see some of the attributes. So first attribute is ndim. So ndarray.ndim will give you the dimensionality of that particular nd array, which gives the number of dimensions of an array as an integer value. Array can be one-dimensional, two-dimensional, or n-dimensional, and so on. Array has two axes. Row axis is called as axis 0, and the column axis is called as axis 1. The number of axes is also called as array's rank. So if you specify array.ndim of array 1 will give you 1, because it's a single dimensional array. But on the other hand, array 3 dot ndim will give you 2, which means it's a two-dimensional array. So ndim will give you the dimensionality. Coming to the next attribute called nd array shape. It gives a sequence of integer indicating the size of the array for each dimension. That is, for example, array 3 dot shape will give you 3 comma 2, which means it has 3 rows with 2 columns. 3 rows with 2 columns. The output 3 comma 2 means the array 3 has 3 rows and 2 columns. So empty array size is another attribute. It gives the total number of elements in the array. This is equal to the product of element shape. In the case array 3, we had 3 comma 2. So the size is going to be of 6. So 3 into 2, 6. So 6 elements are going to be there in there. So size will give you the number of elements. And the next attribute is data type, D type. Any array dot D type is the data type of the element of an array. All the elements of an array are of same type. The common data types are int 32, int 64, float 32, float 64, u32, etc. So in the previous example, array 1 is of int 32, array 2 is of u32, and array 3 is of float 64. The next attribute is going to be item size. NDArray.item size. It specifies the size in bytes of each element in the array. The data type int32 and float32 means each element of the array occupies 32 bits in memory and 8 bits from a byte. Thus, an array element of int32 has an item size of 32 bits. 32 divided by 8, it is going to be 4 bytes, and similarly for int 64 means it has 8 bytes of memory location reserved for each element. So for example, array 1 dot item size gives 4, which means each element is going to occupy 4 bytes of memory location. And similarly, array 2 dot item size will give you 28, which means it is going to occupy so much of memory space. And array 3 dot item size will give you 8, which means it is a floating point number. It is int float 64, which will occupy 8 bytes of memory. Creating ND arrays. We can create arrays in many ways. Some of them are, you can, for using NumPy, you have to import NumPy as NP. And here we are converting a list into NumPy array. So there are 2 lists available, and it is converted into a NumPy array of data 2. So it is, these 2 lists are stored in data 2. This data 2 is converted into ND array by using np.array. Now array 2 is of the type NumPy array. Now we can print the dimensionality of the array and the shape of the array. So dimensionality, it is 2-dimensional, and shape of the array, 2 rows and 4 columns. So this is how we can create ND arrays. We can create ND arrays in many ways. Here are some examples how we can create n-dimensional arrays. So the previous example, you can specify the list here, and using np.array, you can convert it into an array. This is going to be a 2-dimensional array. And there are many other functions available. Zero function, np.zeros will create the dimension given here with zeros. Here we are giving np0, 2, 3, which means we are going to create a 2-dimensional zero array with 2 rows and 3 columns. All the elements of the array is going to be of zeros. And similarly, np.ones, you can create array with number 1 alone. And similarly, np.I is going to create a unit matrix. So you are going to give a 3 cross 3 unit matrix. Similarly, array.np range. This arange function is similar to the range function that is available in NumPy. Here we call it as arange, from 0 to 10 in terms of step 2. So from 0, step 2, 2, then step 2, 4, and so on, up to 10. This is 10 is the last element which will not be displayed, up to 10. The previous element of 10, 8 is available here. And similarly, random int is another function available for creating random numbers. Here you are going to generating random numbers from 0 to 10, and you are trying to create an array of 3 cross 3. So 3 cross 3 matrix with random numbers in the range 0 to 10 is being created. So these are the various methods by which you are going to create n-dimensional array. Now coming to the indexing and slicing. So these are the important operations that can be performed on Numpy array. So here we have taken an example. So one-dimensional array are simple. On the surface, they act similarly to Python list. But the operation that can be done on ND array is going to be different. That we are going to discuss here. So we are creating an n-dimensional array, np dot a range of 10. It is going to create 0 to 9, some 10 elements. An array is created. We can print the array, and we can print what is the position 5. Print array of 5, fifth position, that is position 0, 1, 2, 3, 4, 5. So fifth position, we are going to have value 5. And in indexing, we can use two parameters, the starting value and the end value. So array of 5 colon 8 means start from position number 5, go up to 8 minus 1 location. So that is 7. So 5 to 7. So you go to this particular array, 0, 1, 2, 3, 4, 5 is 5, 6, 7. So 3 elements are being displayed for this command 5 colon 8. If you want to change the value also, you can. It is ND array is mutable. So 5 colon 8, we are assigning a value 12. So instead of 5, 6 and 7, the value 12 is going to be displayed here. So it is mutable. You can change the value of the Numpy array. Continuing indexing and slicing, you can assign a scalar value to a slice, as in the case of array of 5 colon 8 to 12. The value is propagated and broadcasted to the entire selection. So there are 3 values which are being selected. This value is being propagated to all the 3 values. An important first distinction from Python's built-in list is that array slice are views on the original array. This means that the data is not copied and any modification to the view will be reflected in the source array. So we'll take some examples. We are taking the same example of a range of 10. So from 0 to 9, some values are there. We are printing it. And array slice 5 colon 8, it is going to display these particular values as in the previous example. Now we are having a new value, array slice of 7. So in the position number 7, we are trying to insert this particular value 1, 2, 3, 4, 5. So instead of this particular value 1, 2, 3, 4, 5 is being substituted. And similarly, array slice is going to have the value position number 5, 6 and 7. To that particular array slice, we are assigning a value 64, which means to position number 5, 6 and 7, you are assigning value 64. So these are some of the slicing or indexing operations that can be performed. So to continue the slicing, to extract a part of an array, this is done through slicing. Define which part of an array to be sliced by specifying the start value and the end index value using start colon end. So that's what we have been using along with the array name. So for example, in the case array 8, 3 colon 5. So start from 3, go up to 5 minus 1. So which means go 3 to 4. So you go to this particular 0, 1, 2, 3. 3 is value 10 and 4 is value 14, that is being sliced. So from this particular array we are slicing. So for slicing we are going to have the square bracket with the start colon end position. And to reverse an array, the same slicing we can use it for reversing an array. The same array we are displaying array 8. Double colon means extract all the rows and columns in the reverse order. In the reverse, minus 1 means it in the reverse order. So from 20 to 18, it is displaying in the reverse order. Indexing. In a two-dimensional array, the list at each index are no longer scalars, but rather one-dimensional array. So here, though you are having multiple lists combined to form an n-dimensional array, they are no longer scalar, but they are going to be one-dimensional array. It is being treated as one-dimensional array. For example, array 2D, two-dimensional, second position. We are trying to print the second position. This is position number 1, position number 2, position number 0, 1 and 2. So we are trying to print the position number 2. It is 7, 8 and 9. So that's the output display. So these are equivalent. These two. That is, you can specify the row and column and find out the value also. So this is in the two-dimensional array. Zeroth row, second position. Zeroth row, second position. 0, 1, 2. So value 3. So either you can specify square brackets or you can simply specify this position. It is going to be one and the same. So this is how you can index a particular element or group of elements in an array. Now coming to operations on arithmetic or arrays, we are going to see some arithmetic operations. Arithmetic operation with scalar, propagate the scalar argument to each element in an array. Suppose if you want to multiply an element of the array, each element in the array will be multiplied. For you, you are going to have an example. So you are going to have 1, 2, 3 as list, 4, 5, 6 another list. It is converted into a NumPy array and it is stored in a variable called array. So you print the array, you have 1, 2, 3 and 4, 5, 6. Now print array double star 2. So array to the power 2. So which means all the element in the array will be square. So 1 square, 2 square, 3 square, 4 square, 5 square and 6 square. So it is being propagated to all the elements in the array. And you have one more array, array 2 with the different values. And we are checking for the logical operation array 2 greater than array. So there is an array 2 with these values and there is an array with this 1, 2, 3, 4, 5, 6 and so on. We are trying to compare each element. So array 2 greater than array, which will check each element, and if it is true, it is going to give you true, and if it is false, it is going to give you false. For example, the first value is 0 in array 2 is greater than 1. It is false. So the value is here false. Similarly, all the elements are being combined and the result is displayed. So continuation of arithmetic operation. Arithmetic operation NumPy arrays are fast and simple. When we perform a basic arithmetic operation like addition, subtraction, multiplication, division, etc. on two arrays, the operation is done on each corresponding pair of elements. Consider the following element-wise operations. You have NumPy array 1 and array 2. And if you add array 1 plus array 2, each element will be added. So 10 plus 3, 13. 20 plus 6, 26, 15 plus 4, 19, and 12 plus 2, 14. So operations are done pairwise when you are going to do some binary operations. And similarly, subtraction also, each element will be subtracted. And for multiplication also, you can multiply two arrays. The first element of first array and first element of second array will be multiplied. And similarly, you can have multiplication also. Exponentiation, division, all arithmetic operations are possible with respect to this NumPy array. Now coming to this transpose. Transposing an array turns its rows into columns and columns into rows. So you have an array, NumPy array in the name of array 3. We have created, we have displayed. Now to take a transpose, array3.transpose is the command. So that will convert the row into columns. So 10 minus 7, 20, 10 minus 7, 0, 20. So that row becomes a column. That's what is called as transpose. By means of dot transpose, we can find the transpose of an array. And sorting. Sorting is to arrange the elements of an array into hierarchical order, either ascending or descending. By default, NumPy does sorting in ascending order. For example, you have a NumPy array, array 4 with values 1, 0, 2 and so on. And array 4.sort will sort it in the ascending order. So minus 3 first, 0, and so on. It is available in the ascending order. So by default, sorting is done row wise, that is axis 1. It means to arrange the element of each row in ascending order. But when you specify axis 0, it is column wise, which means each column is stored in ascending order. We can see an example of array. So numpy array we have created, and this is the array. Now if you want to sort it, array 4.sort will sort row wise, and here you have one more array called array 5. Now we want to start this in column wise, so we are specifying array 5 dot sort axis 0, where column wise it is being sorted. So row wise sorting and column wise sorting, you can specify axis 1 and axis 0. By default, if you do not specify anything, it will take it as axis 1, and row wise sorting will be done. To summarize, we have discussed about array, numpy array, and we have discussed about what is indexing and what is slicing. We have also discussed about various operations on arrays, such as arithmetic operation, transpose of an array, and sorting of n-dimensional array. I think we have completed part 1 of NumPy, which is a powerful library available in Pandas. And in the forthcoming sessions, we will continue the NumPy part 2 with various other functionalities available in NumPy. Thank you.